to try out federated speech. So we would come to the next talk now, which would be Jiajun, Chief AI Scientist at TCL Research, and previously also at Facebook AI Research. Jiajun will be presenting the huge potential combining unsupervised methods and federated learning, especially in the context of video, where there's a project recently underway with collaboration with Flower and Cambridge. So, Jen, I think you can take over.
Okay, let me know can you guys hear me? All right, perfect. So thanks for the introduction and the invitation. Today I want to share some problems that we have been thinking about at TCL Research and how federated learning could be some part of the answers to these real-world problems. More specifically, the title is Perceive and Reason with OnDevice AI. Well, towards a better understanding of the world. It's a long title, and it's also quite a big title, which probably will require a whole afternoon session to cover. But let me briefly tell you what is it and why is it important and how federated learning plays an important role in this. So for those who are not familiar with TCL, the current company I'm working with, it's an electronics company that designs, develops, and manufactures TV, mobile phones, air conditioners, refrigerators, and other electrical appliances. Therefore, as you can probably imagine, the company is particularly interested in bringing smart life experience to the customers. So, well, a smart home is not an unfamiliar terminology in our everyday life. Now, you know this already. You might already use it in day-to-day life. However, when you think about it, it's not actually very smart. You are still required to sort of take off your phone and talk to Alexa to execute your commands. Here, I show a screenshot of when I type in smart home in Google image search. Among these dozen of images, you can see lots of them has either a phone or a fingerprint or a finger in this image, showing that the users or the customers are still in charge of like all those different devices in the system. Of course, they are certainly important. However, it would be really great if we could have some smart brain that could perceive the environment, condition, customers' action, reason about their intentions, anticipate their reactions, and hopefully react to assist those like customers in a very useful way. So that is why it is very important to develop this kind of capabilities if we truly want to build an AI for a smart home. So that's why like perceive and reason are quite important in our like smart home environment. So how do we do that? Well, there are so many informations about the world. If you really want to perceive and reason about this word and get a better understanding about this word, there are so many different informations. So lots of the word's information is organized as a structured information, as we show here. The social network, there are knowledge graphs, there are scene graphs. You need some techniques to embed those knowledges from the graph. So basically, we can get those representations for as many entities as possible in the physical world, and based on those structured information. Now, there are also other, semantic informations. One of the biggest topics in AI in the last 3 years is large-scale model pre-training. From 2018 to 2020, we have large-scale pre-trained NLP model from 117 million parameters to 175 billion parameters. We've also seen folks start to mix things together. Works like DAL-E and CLIP combine different modalities together and move sort of a step forward towards having a better understanding of the world with semantic information. There is so much work ahead of us. I talked about like mixing different data modalities, but there are also like different other modalities like audios and videos. But there are some practical challenges if we want to, move forward with this type of research. The one issue is with the data. Everyone knows it's quite costly to annotate the data. Even for the unlabeled data, it's also quite trivial to collect, especially if you want sort of collect large-scale data set for a particular task. Lots of issues involved, for example, the authenticity of the data, the correctness, most importantly, the possible privacy issues you might have when you collect those data. Now, even if you have these data, there are other issues. For example, now you have a large-scale data set. Where do you want to store it? And it could probably take you a fortune to store those data. And sometimes it could require you to transfer from different sources to a centralized computation center. Data transfer can be a pain as well. On the other side, there's the issues with the resource. All those breakthroughs in the machine learning in the last 5 years come with a huge computational costs. Every 3.5 months, we are seeing a doubling in compute. As you can see the figure here, it's from the OpenAI blog post. So this is what made it really hard to make the model run. So these are the practical issues we're running if we really want to perceive and reason about the world and understand the world. So therefore, we think to solve the above-mentioned problem, we turn to OnDevice AI. So many researchers have predicted OnDevice AI is going to be the future. With OnDevice AI, we think it will have an unfair advantage of seeing so much more data over a centralized computation center. So therefore, we think in the future, it will definitely replace the centralized computation center as a heart of AI. And because it has unfair advantage of seeing so much more data, it will the slip-arc accuracy will come from efficient ML models. Of course, this also requires lots of other development in the entire AI community. For example, self-supervised learning. Now let's turn to federated learning. Federated learning offers a framework to learn models from decentralized data, which provide a solution to alleviate the data privacy concerns that we just talked about, while taking advantage of the growing computation power of the edge devices. So this is actually quite ideal. Now, like what just mentioned, the host just mentioned, as a baby step, we are actually taking initiative and to see if we can, you federate some of the unsupervised approaches especially for videos. Now, perceived and reason, we talked about, folks have been working on images and combining natural language and computer vision tasks together. We think we want to move it one step further. We want to, learn from every video that without annotation. So this is basically about, self-supervised learning from videos. Lots of folks have shared the same vision. There are already lots of works in this line. There are 3 different types of solutions to do self-supervised learning for videos. One is you can define some pre-tested tasks. For example, you can separate the entire video clip into 3 different clips, and then for some of them you speed them up, for some of them you slow them down, and you want the neural network to predict the relative speed of those video clips. And also you can, for those 3 different videos, small short clips, you can shuffle them, and you want the neural network to predict the temporal order of those different clips. And also folks have tried to borrow ideas from the 2D image self-supervised learning. They can do 3D jigsaw puzzles and try to reorder it so that the video actually makes sense. There are different, another direction is contrastive learning, which has been quite hot topic in 2D image self-supervised learning. Essentially, you want to construct those positive and negative sample pairs, so you want the embeddings for those positive pairs to be pulled together, and you want to push away those negative pairs. Well, there are also some issues with that. And another different direction is cross-modality. Of course, you want to use other data modality to supervise the video learning. So for example, you want to sync the video with audios, you want to sync some captions with the video content as well. Now, as a first baby step, we really want to, take one of these approaches or a few of these approaches. And I'm trying to understand if we want to federate them, what will it look like and what problem will we run into. So there are still a few big ifs before we can move forward. If we really want to understand the world using this kind of techniques with federated learning. So a few research questions we have is, first of all, if the algorithm, whatever the either is going to be the self-supervised learning video understanding algorithm or is some other algorithm, if it can be run efficiently on heterogeneous devices, for example, if they have different computation power, different bandwidths to synchronize those gradients, what will happen? And if those algorithms are still effective, if the data is non-ID, I think the previous speaker just talked a lot about this topic as well. And I think the most important of all, whether, like, of course, there might be some performance gaps of different algorithms after being federated, but we were trying to understand how big that performance gap is and whether it is possible to shorten such gaps, especially, it's going to be very important to make our vision come true. So by the end of this talk, I think you probably have more questions than answers, but that's good. That means that we have more work to do. And with that, I think it concludes my talk. Thank you for listening. And if you have any questions, do answer.
Thanks a lot, Jiajun. It was a great talk. We actually have a question here, and that is, what do you see as the biggest challenge for the large-scale adoption of federated unsupervised video understanding on edge devices?
Right, that's a great question. So I think one thing is, like, we really need to have a systematic study about how the current self-supervised learning for video understanding can be federated. Like, when we federate such algorithms, what issues we will run into. Like the things that I talked about, if we can figure out, if we can have a systematic study on different algorithms, and if they can be run on heterogeneous devices, if the data collected are non-ID, what will happen? I think the non-ID part is especially interesting because now we're talking about, the data collected from different devices might have a different data distribution, and then suddenly these kind of federated learning algorithm might not work anymore. So we need to have a very good understanding about that before we can have a wide adoption about with this federated learning approach. Of course, we also need to experiment with different approaches and see what is the performance gap. Let's say even if the data distribution is ID, the end devices are homogeneous, and will that going to be a performance gap if we federate the current algorithms? And if there is, how big is that? Is there any possible solutions to alleviate such a performance gap? So that will be a few questions we need to answer. But once people have a better understanding about this problem, I think a wider adoption will be quite natural for the researchers.
Thank you. I think there's another question which came up, which is, if we deploy a model to the clients that will generate the soft labels, in addition to the global model we are trying to train, does it make sense to also let the soft label generator evolve between the rounds?
Does it make sense for what? Sorry.
To let the soft label generator evolve between the rounds.
To evolve between rounds. Well, the short answer is I don't know. I think we have to see, but I feel like yes, it really depends on like how quickly those data distribution shifts. I mean, like if you have a soft label generated by the user that's quite different from the global model, then yes, I think we need to update that. But like hopefully, those shifts are not happening that fast, and the global model can still be of some good usage. But yeah, it's really dependent on the real use cases, and I guess we have to see in real applications.
Thank you. So to stay in time, I would go to the next talk. Thanks a lot for your time and for the presentation.